Okay, so this is problem number 24 from Hall and Knight Higher Algebra, Chapter 1 Ratios. Again, we have been given two equations. This is equation number 1 and this is equation number 2. And we have to find, or we have to prove, that this relationship is true. Okay. Again, the problem is not difficult in terms of the concept, because in terms of concept, what you have to do is you have to simply use the rule of cross multiplication that we have seen in many problems before. However, because it has some radicals involved in the coefficient, this problem is fairly involved in terms of algebra. Other than that, there is nothing complicated in this problem. So what we know is that the ratio will be something like L over P is equal to M over Q is equal to R over is equal to N over S. We'll get the relationship something of this kind, and let us say that this ratio, all of this is equal to K. We have to get the relationship of this kind. However, what is P, Q and S, we have to calculate. So for calculating P, what we know is, for calculating P, we have to multiply these two terms and subtract these two terms. This is the rule of cross multiplication. So in order to make it more clear, let me write all these coefficients separately. So we have coefficients of M as 1 by root B minus root C. Coefficient of N is 1 by root C minus root A. Coefficient of L is 1 by root A minus root B, and we will repeat again the coefficient of M. So coefficient of M is 1 by root B minus root C, and we repeat the same for equation number 2. So we have coefficient of M as 1 by root B plus root C, 1 by root C plus root A, 1 by root A plus root B, and coefficient of M again, which is 1 by square root of B plus root C. So from here we can find what is P. P is equal to, we have to multiply this term and then subtract from this term. Okay, so if you multiply this, you get 1 by square root of B plus square root of B minus square root of C times square root of C plus square root of A minus 1 by square root of b plus root c minus root c minus root a. Okay, so if you take the LCM of the denominator, what you can see is you have to multiply all these terms. So root b minus root c and root b plus root c. This is simple formula of a minus b, a plus b. So this will be b minus c. That is, if I multiply this term and this term, I get b minus c. And similarly, if I multiply this term and this term, I get c minus a. And then I have to multiply these two terms in the numerator. So this is root bc so in the numerator we have root bc minus root ab, okay, plus root c times root c is c minus root ca, okay. This whole thing and you subtract root b times root c, so you have root bc plus root ab minus c minus root ac. So I hope this is clear so far. Now we simply have to expand and see the value of p. So in the denominator we have b minus c, c minus a. Now you see that this is root bc minus root ab plus c minus root ca minus root bc minus root ab minus minus is plus c and minus minus is plus root ca. So this root bc and minus bc cancels, minus ca cancels with this plus ca, and we are left with c plus c is 2c minus root ab minus root ab is minus 2 root ab divided by b minus c and c minus a. This is equal to, we take 2 as a common factor out and we get c minus root ab over b minus c and c minus a. So we have the value of p. Similarly, we can calculate the value of q and calculate the value of r. However, in these kind of problem, it is very important if you see that there is a symmetry in the coefficients. For example, you can see that this is root a minus root b, root b minus root c minus root a. That is, it has just been cycled over. Similarly, in the second equation it is root a plus root b plus root c, and root c plus root a. So over here also this has been just cycled over. So once you know the value of p, we know, or we can at least guess what the value of q and r going to be. Okay, so if p is equal to this, that is, this is equal to p, what is the value of q going to be? We just have to simply cycle it over. What comes after c? After c will come a. Instead of AB, what it is going to be over here? It is going to be BC over here. In the denominator, instead of B minus C, it is going to be C minus A. And instead of C minus A, it will have A minus B. This is how you can recycle and find Q. Similarly, you can again cycle through these variables and you can find R. There will be 2. Instead of A, it will have B minus BC will change to CA, C minus A will change to A minus B, and A minus B will change to B minus C. So now we know the value of P, Q and S. I'm sorry, over here I think I have called it R. So let us, instead of changing here, let us call, instead of S, this is R. Okay. Now what is it that we want to prove? We want to prove that L over A minus B divided by C minus root AB is equal to M over B minus C divided by A minus root BC. First, let us find out what can we write about L. L can be written as P times K. Okay. So what is P? P is 2 times root C minus AB, B minus C, C minus A. Times root C minus root AB divided by B minus C and C minus A times K. So L over A minus B C minus root AB will be equal to 2 times K over A minus B over B minus C over C minus A. You can see that C minus root AB, I have just brought it down to this side in the denominator, and after that I have just, because I have divided L by A minus B here, I have to divide this side also by A minus B here. So we have already shown that you can see that this expression over here is equal to this expression over here, and the value of this expression is 2k over a minus b over b minus c over c minus a. So similarly, by symmetry again, you can prove that each of these expressions, that is L over a minus b times c minus root ab, this will be equal to m over b minus c a minus root bc will be equal to n over c minus a times b minus root ca. Each of these ratios will be equal to 2 times k over a minus b, b minus c, and c minus a. And because each of these ratios is equal to 2k over a minus b, b minus c, c minus a, we have proven that this expression over here is actually equal, as this relationship holds. Each of these ratios is equal to 2k over a minus b, b minus c, c minus a. I hope you have understood this problem. I do agree that the algebra involved was quite hairy, but I have tried to explain as much as I can. If there is any confusion, you leave me a comment and I will reply you. Thank you.